Today we're going to spend more time with linear quadratic systems, but it won't be so obvious with the substitutions. So for example, the first problem, number 1, we're given y equals the parabola x squared minus 4x and the vertical line x equals 4. Now don't worry so much about the multiple choice, but when I want to go through here with the substitution, when you plug in 4 in for x, you use orders of operation, you get 16. It turns out this vertical line is tangent to the parabola and it touches it at exactly one spot. So it is possible to have a vertical or straight line touch the parabola at one spot. The most would be 2, and it's possible it doesn't touch at all. So example number 1 here, just a nice straight up vertical line, plug in the 4 in for x. But example number 2, it too would like to know when the system of equations y plus 2x equals x squared and the line y equals x is graphed on the same set of axes, what is the total number of points of intersection? Well, again, using algebra, we're just going to directly substitute in x where we see the y. So we end up getting here x plus 2x is equal to x squared. Combine like terms. But when I saw this problem, I wanted to make sure I review this with you because you should not divide both sides by x. You lose an x-intercept. You need to subtract the x, move it over to the other side, see how I keep the a value positive, factor out the GCF x, and we do discover there are actually 2 different points of intersection. Now don't forget, once you find your x value of 0 and 3, we're still trying to find points of intersection. You need to go back. You could do eeny, meeny, miny, mo. This is so much easier because this tells me the x and y values are the same. So if x is 0, the y value is 0. X value is 3, so too is the y. Now remember, these are ordered pairs, so don't forget to put parentheses around your points to indicate we have an ordered pair. The last example I wanted to try was question number 13. And the reason why I wanted to go over 13 with you is the substitution may not be obvious. You might think to take the x squared minus 6x plus 10 and plug it in here y, which is fine. You have to combine the like terms and bring the 4 over because before you factor, you've got to make the trinomial set equal to 0. But I thought maybe I might review with you, why not use slope-intercept form? So remember, slope-intercept form, you would subtract x from both sides, so hence the line in slope-intercept form is y equals negative x plus 4. Now you can set the y's equal, so negative x plus 4 is equal to x squared minus 6x plus 10. I just added x to both sides, subtracted 4, and voila, I get a very nice trinomial, factors wonderfully, using my factors of numbers and multiply together give me 6, add to negative 5, negative 2, negative 3. So I do get 2 answers, 2 roots, 2 x-intercepts, well, not 2 intersections, so 2 different x values. X is 2 and x equals 3. Now remember, either one is fine to plug in. You might as well plug it in here. It's ready to go, right? So if x is 2, I actually have negative 2 plus 4, so the y value that matches that is 2. The x value is 3, negative 3 plus 4, the y value is 1. And notice the parentheses. So this worksheet, what I'd like for you to try for homework then are examples number 6 and 7, just more practice helping you with linear and quadratic systems. If you have any questions, just let me know. Send me a message on Remind or an email or a message on Google Classroom. Thanks. Have a great day.